So hi everybody, welcome aboard. So in this week we are going to go and do a little bit of cryptography. Okay, so before we jump into the lab, we just want to go through a bit of theory, just a very basics of it, so that you understand what you're actually doing in the lab. So cryptography is basically two things mainly. There are two parts to cryptography. One is encryption, okay? One is hashing. Okay, I hope you have heard of both of them. So we are going to focus on encryption on this lab. Okay. Hashing is something which is out of the scope of this lab, but I will just explain that to you just in case. If you know. Okay, so in encryption, we have what happens in encryption basically. So you have a plain text which is easily readable. It's in English or any language which is readable by the by a human. You can easily read it. It actually goes through a model, a mathematical model where you actually encrypt it. So there are several mathematical models, and after it goes through that, it is changed into a ciphertext. Okay. So this is the ciphertext which actually is not readable. It's readable, but you can't actually understand what's there. All right. And similarly, if you want to decrypt the encrypted file, you use the same parameters as you use in encryption, and you get back your text. Okay, so basically we do it for privacy. We do it so that nobody else can read our data on the way. Okay, even if they're eavesdropping, it's difficult for them to understand. All right. So now in hashing, as compared to that, you do everything the same. You have a text, right? And you put it through a model hashing algorithms, okay? And it generates a hash for you, okay? A hash is a fixed value, which depending upon which hashing algorithm you're using, it generates a fixed number of characters, a value. It acts as a fingerprint. Okay, you use hashing mostly for integrity. You want to just make sure that the data you're receiving is actually not being tampered with. Okay, and hashing as compared to encryption is one way. So you cannot actually reverse it. Hashing cannot be reversed. All right. So for example, if you want a file from the website, you have a file on the website, you want to download it, and the guy has also shared the hash with the file. You download the file, you create a hash, and you compare that the hash of the file you got and the hash which what the provider has provided matches. If they match, this means it's a legit file. It's not been tampered. Okay, so mostly the hashing is used in that case. So this is something which is out of the scope of this lecture. So we're not going to go into the hashing, but as much as I can, I will explain that on the go. Now coming to encryption, the basic idea is to encrypt the text to cipher and back to decrypt. There are actually two parts to it. There are two types of encryption mainly. So the first type of encryption is, so encryption has two types. Basically, one encryption type is where you actually use one key only. All right. In this, we call it a symmetric encryption. Okay, I'm using my mouse, so I can't type. So this is a symmetric encryption. Symmetric encryption. Now, what happens in symmetric encryption, for example, if the typical example of security where you have Alice and Bob, they want to communicate with each other. What they would do is they would have a key. So if Alice wants to send anything to Bob, Alice will have a key, and Bob will have the same key. All right. So Alice will encrypt the data using the key and send it to the to Bob. Okay, Bob will use the data which is received using the same key. It will decrypt it and then read the data. Okay, that's how this is based on. But the problem here comes in if you have, let's suppose, Alice wants to communicate with someone C and D and, you know, E and F. Let's suppose, you know, so many people. So Alice or A have to keep the key for each one of them. So these keys should be different, right? So that you have privacy. Otherwise, C can use the same key which B is using. So for all of these, A will have different keys. Okay, so A have a keychain where it will have to keep the key for every person A wants to communicate with. So let's suppose on average we have, you know, so many people we talk to every day, so many places we go to, we have to keep keys for everything. So you get the idea. It's not very scalable. It's not very, you know, it's not very efficient. So, and more importantly, the problem comes here. How will you exchange these keys so that nobody else actually has that key? So that itself is a big research topic, which again, it's out of the scope of this lab again. So it's clearly not a very feasible way to do using symmetric encryption, but this is a point where we started from, so it's all good. Now we have an improved version of that. Of course, we use 2 keys now. Okay, and this was introduced by 3 scientists, and based upon this, we have, you know, their algorithm called RSA, and based upon which actually our internet relies nowadays. So RSA, these 3 scientists actually came up with an idea where now instead of having 1 key, Alice will have 2 keys. Alice will have 2 keys. 1 key will be the private key. Okay, so 1 key is the private, and A will have another key, which is a public. Okay, now the private key, which A has, it will never be shared with anyone at any case, never. Only A knows about that. Okay. And using, I mean, using the so the public key is also associated with private key. All right. So anything which is encrypted using the public key can only be decrypted by using its associated private key, which only A has. So now if anybody out there, let's suppose B, wants to communicate with A, so A will send the message using the public key of A, right? A will use the public key, B will use the public key of A. Public key is available to everybody. So B will use the A's public key, encrypt the message, send it to A, and A will use its private key to decrypt the message and then read it. Anybody in the middle will not be able to, you know, decrypt it because they don't have the private key. Okay. So that's the whole idea. This is this makes sense, you know, it's very, very useful. And this is what is the basis of today's lecture. Okay. Now the idea here comes in, the one small issue here is, what if somebody else comes in the middle and say, hey, I am actually B. A cannot actually, you know, make the decision if the message is actually coming from B. All right. So in this scenario, we have something called a third party, a certificate authority, which everybody trusts. So A trusts certificate authority, B also trusts it. So now if anything is sent by B to A and A receives the message and it says, hey, I am B, A will always check it with the certificate authority and verify and say, yes, that is B. And from then onwards, you know, you can trust that, yes, the message is coming from B. All right. So certificate authority is one major portion of today's labs. So you have to understand that portion as well. It's just like if you are on the road and you got pulled over by the police, for example, and you show him the license, which you have actually printed at home. Okay, everything is legit. Your picture is there, your name, your date of birth, everything is perfect. But that is something which a police officer wouldn't trust, right? He would have to actually seek help of the third party. All right, that can be anything, right? That is where in the internet, in the browsing, we have a certificate authority that we actually need approval of. We need certificate from the certificate authority so that everybody can trust us, and not just any CA. It has to be a CA which everybody trusts, which your browser trusts. Okay. So yeah, that is the gist of today's lecture. I mean, the lab. And let's jump into the lab now. If you have any questions, let me know or send it in the chat. Yeah, private key is used to decrypt the message. Yeah, that's right. Okay, so I've gone through the basics of the lab. In today's lab, we are only going to use the CyberSec server. So please make sure your CyberSec server is turned on, it's active and ready to go. We only need CyberSec server for today's lab. SSL is something which actually is very helpful to understand if you want to. You have an OSI model, right? At layer 7, the application layer. You have some protocols, and SSL is actually layer 4 protocols. So let's suppose this is layer 4. So at layer 4, you have SSL, TLS. So basically what these protocols do, they provide encryption to any protocol which is at layer 7, for example, HTTP, and doesn't have encryption. So SSL actually provides encryption to HTTP, and we see that is called HTTPS nowadays. All right. Okay. So before the encryption, the world was like this, where everything was sent unencrypted. Anybody can, probe in and capture the data and read it clearly. But we have started using SSL TLS, and then there are different versions. Maybe I think there are TLS version 2 and 3 even now. You should at least use the latest version possible. I've told you what is a private and public key. Yeah, I've told you about that. Also certificate authority, I've told you about that. Now certificate authority, one thing to note is it follows a standard. Okay, so that everybody follows the same standard. We have a standard named X.509 that everybody follows and understands. Okay, you can generate your own certificates by using SSL. So there is a open source software, OpenSSL, which we will use today to generate our certificates, and you can create your own certificates. But the thing is, who's going to trust you, right? So you will save money because unlike as a CA which everybody trusts, if you want a certificate from that CA, you will have to pay the fees, right? You have to pay the fee for that, and that certificate has an expiry date, just like our driver license, passport, and that certificate can get revoked, okay, if it expires, or even if the private key has been compromised, okay? So just like anything, there is an expiry date to that. So the point is you can create your own certificates, but the issue will be nobody is going to trust you. So, but we will create our own CA today. We will trust it, and we will call it a root CA. So to create those certificates, there is a free open source project, OpenSSL, which we will use. It's a toolkit. You can actually look into it. And we will be using it throughout for all the tasks. Okay. So today we have 4 tasks. In first task, we will simply just use a file, any file. We will encrypt it using some parameters. We will give it certain cipher and key. and we will decrypt it using the same cipher and same key. Okay. So we will do encryption and decryption in the first task, and tasks 2, 3, and 4 are related to each other. In the first of the next 3 tasks, we will be, first of all, becoming a CA. So we, being a CA, need a public and private key. Anybody who's communicating needs actually a pair of that, right? So a CA needs a private and public key. We will generate that, okay? And then we will actually have our first client who will request us to give him a certificate, okay, which he can show off, right? Put it on the browser. And using that certificate, we will see how we can actually put that on the browser and make it work. So these are the 3 tasks which are related to each other. So first task first, let's start with the first task. So for this task, you have been given a folder on Canvas by the name of crypto files. So please download those files. It's a folder, download it and put it on the desktop of your virtual machines, please. Okay. So what it means is I have actually gone ahead last night. I had, I'm using MacBook M1, so I can't use any virtual machines, unfortunately. So that's why I wasn't able to actually demonstrate anything. But I have a very old laptop, which is actually 9-10 years old. It's a MacBook again. Last night I went on to that. I actually thought I will be using that laptop. I downloaded Fusion Player, not the Pro. And then I booted up all the virtual machines and everything worked fine. Now what I'm doing is using my new laptop, I'm actually remote desktoping into the older one. And that is how you're looking at this. This is why you're seeing this as a separate screen, okay? But just to show you, just last night I downloaded it at around 8 p.m. Even the virtual, the Fusion is this version 12. And yeah, just this morning at 7 a.m. I downloaded these files. So your first step is to download these files. Okay. So copy these files or drag these files to the virtual machine's desktop. My virtual machine is actually locked. So let me go ahead and log in, CyberSec. And
sorry, where did you say the files can be downloaded?
UTS Canvas in the folder of this week. So I'm going to delete everything which I did with the previous class. Just close this as well. Maybe close this as well. Okay. So first thing, so you go to your, wherever you have downloaded the files, just drag these files to the desktop. Okay. Create a folder, crypto files if you want. I suggest you do, and copy these files into the crypto folder. Okay. There are files, but I'll replace them anyway. And you see, I have the files there. I'll just delete these ones. Anyway, on my desktop, I have crypto files folder. And if I double click, you can see I have, scroll back. So you see, I've just put the files in the crypto files folder. Okay, so this is the first thing you need to do. Make sure you put them on your virtual machine and put them in the folder. I mean, it doesn't matter. If you know how to navigate through the Linux, it should be a piece of cake. So we are actually executing all the commands on the terminal. That's why I need to go to the terminal. Let me just put them side by side. And you need to be in the same folder, right? So if you check your current directory by executing pwd, PW means print working directory. It will tell me that I'm in home server/sec server. Okay. And if I want to use the files here, yeah, you can just follow what I am doing. So yeah, just put in the same folder. So I have put it in crypto files folder on the desktop. So I will go to the desktop, and there you go. I have crypto file folder there. It's created, and I will go to the crypto files folder and look at the file. I'm showing I have the file. Okay. So when you do a PWD, you should be
we
in the
can't.
crypto files folder.
Sorry, we can't hear you properly. I think your voice is glitching.
I think it's better now.
Yeah.
Okay, so what happens is we have just created a folder on the desktop by the name of crypto files, in which we have these files which you downloaded from UTS Canvas, and I am going to the same directory on the terminal at the same place. Okay. So now that I'm in the same path as my files, I can actually now encrypt the files and decrypt them as per the slides. Okay. The first thing, you need to download the folder, put them in the desktop on your virtual machine. And yeah, now once you have that ready, you can actually take a look at OpenSSL. If you want to see the manual of OpenSSL, this is just going to give you all the possible commands of OpenSSL. And the other way to look at it is OpenSSL. If you just want to look at the ciphers, encrypted ciphers, encryption engines, you can use this command. So you see it has all these ciphers available. Okay, so whichever is you are going to use, for example, if you use this cipher, make sure when you're using it to encrypt the file and you get the file ciphertext, you are using the same engine or same cipher to decrypt it. Okay, so we have to use the same cipher for encryption and decryption. Okay. And then we have to execute this command, and that's a very important one, right? So we are using the OpenSSL. We are going to encrypt using the cipher type, one of the cipher types, all right, whichever we choose. And first thing, we will be using E because we want to encrypt the file, okay? So we are going to encrypt the file, and our input file will go here, right? Whichever file we want to encrypt will go here, and our output file will go here, and our key will be here. You know, you have to use the same key for encryption and decryption. And the initialization vector will go here. Okay, initialization vector, the key and the cipher type have to be the same for encryption and decryption. Okay. Initialization vector is, you know, again, something which CPC uses. It actually puts everything into the blocks, and then it starts from one and then move on further. But anyway, we are using initialization vector, a very simple one, 0.0.0000. So just keep using the same one. Okay, so this is the generic command. All right, let's see that in action. So when you look at the clear text file, you will see everything is readable. It's in English. After you encrypt the file, you will see something like this, which is difficult to understand, right? The command which we are using to encrypt is, if you look here, we're using OpenSSL for encryption. This is the cipher we are using, so cipher are the same. Here we are encrypting the file, here we are decrypting. The file we are encrypting is this one, which we just have, the text file. And we want to, the cipher text should be in this file. This is the name of the file. It can be any name. The key is this 20 digits long key. Initialization vector is 0. So your keys are the same, initialization vector is the same, and cipher is the same. But here we are using decryption. This file becomes the input here. And after you have created the decrypted file, these files should match. That's the idea. Now let's have a look at this in action. I'm going to demonstrate it for you. Let's see how it goes. So first thing again, I told you to copy the files folder on your document on your desktop. Files are here, and on the desktop, make sure you also go to the same here. We'll go again, maybe just follow. First command you should put is cd/root so that you're in the root path. Here, you want to go to the home, the server, desktop, like I'm on the desktop. I don't know where you are. So same, I'm on the desktop and my script files folder. Okay. So what you can do. Yeah. Well, I am there already. I can actually execute the command. First command to encrypt is open. Files are already shared on MS Teams. You can download the PowerPoints and follow them. Okay. If you are lacking, all the files are already on MS Teams. Feel free to download the PowerPoint. So the we are using AES-128 CPC. The input file and the input file, you see the Linux is case sensitive, so please make sure you use proper name. T is capital, underscore is there, F is small. All these things are very, very important. We want to output this file as by the name of encrypted. So it can be any name, just encrypted. So ENC will be the file for key. Key is a long key. The key 1 1 2 2 3 3 4 5 7 6 6 7 7 8 9 9 0 0. Initialization vector 0 0 0 0. Okay. So you can't hear me. Can you hear me now? All right. Yeah, just have to bear with me because I have two computers connected. So this is why the mic is playing with. Let me just go back. Okay, so yeah. So after I've typed the encryption command, all right, I press enter. Brittany, you have the file with you. You have the PowerPoint, so download that and use that. Okay, I'm just gonna finish this and then, come back to you. Okay, so after we've entered the command, encrypted command, you press enter. Probably I did a mistype somewhere. Let me see. Open SSL, ENS, ENC encryption. We are using that encryption cipher. E in text file, out encrypted. The key is there, and the initialization vector. Okay, all looks good. Let me see if my file is there. Yeah, it is. Okay. You see what I did wrong? I mistyped 123 instead of 128. So it says that cipher doesn't exist. Okay, so let's make that correction, and voila, you should see the file there. The encrypted file is created now. Okay, so that's our encryption file. Okay. So now you can actually right click on the file. You can open with gedit. Okay, open with gedit, and you can actually read the content of the file as well. Just like, you see, this is the plain text file, and everybody can read it, all good. And the one which I've encrypted, if I open with gedit, I cannot understand this. I can read it, of course, but I cannot understand it, right? Right, so that is what you have. Now, let me actually decrypt it back to the plain text. And how do we do that? We are using encryption engine, same cipher, CBC. I can't open with gedit to encrypted ENC. I don't know what do you mean. You can right click it and go to open with and search for other applications, show other applications, search for the application here, and one of them should be gedit. Okay, just improvise, guys. It's the same way you use any application. Okay, just right click, find out gedit, and select that, and it should work now. Right. Okay, so I'm about to decrypt it. So what I will use is, instead of E, I will use D. My input file this time is the one which is encrypted, right? And I want to decrypt it out as a decrypted file. I don't want to write it over the existing file, -K. And we have to use the same key, otherwise we will get a different output, which will not be acceptable, and the same initialization vector. And there you go. Once I do that, you see I have a decrypted file created. If I open it, voila, that's exactly the same. All right. How cool is that? Okay. Now to actually go one bit ahead and see if they are actually same, you can actually compare decrypted and text file hash values. How will you do that? So you have SHA 128 sum. It's a built-in Linux command which actually generates the the hash value. So maybe instead of 128, we can, 128 or 256. I think 256 is the latest one. SHA-256 sum, and I want to create the hash of this file. I want to see what is the hash of this file. So there you go. It generated a hash for me. Okay. Text file. So I'm comparing this file with this file. If they are exactly the same, their hash should be exactly the same. Okay. Now let's go ahead and see the hash of decrypted file. So SHA-256 sum of decrypted. Okay. You bet they both are exactly the same. A8BFF here, also A8BFF, and the last bit's 4981A, 4981A. So perfect. They are matching. They are exactly the same files. How cool is that? Now, just to show you, if I go open this file and make a slight change on this, just one tiny bit, just one character. If I just change that character, I delete it. Okay, save the file, close, check the SHA value again, the hash value again. All right, and you see how changed it is. 249 AE. This was different. It's actually totally changed, right? just changing one bit, one character actually changes the hash value. Okay. I hope that has been informative. You have your task 1 done. Okay, so this is what we did. We decrypted the file, and yeah, take a few minutes to do this, guys. I'll pause the rest of the task. Okay, so in task 2, 3, and 4, as I told you earlier, they're connected, and to one another. In task 2, we will become the CA. So to become a CA, we need a pair of private and public key. That's what we are going to do. Okay, so let's take the second task 1 first. Now, since we are in a virtual machine, we have to actually lay the foundation for becoming a CA. We need some files. We need some configuration files, all these tools we need. And then on top of this, we can actually execute the command to, create those 2 keys. So we have to actually work on this part. Let's create that environment first. So first thing first. Again. Steps here becomes CA. First thing is we need a folder. We have to create a folder by the name of CA. Okay, we need a folder by the name of CA, and this folder is under the home directory. Okay, so if you go into the home directory, I'll go into the home directory here, click on the home directory. I'll delete this because this is from the previous. Delete this. All right, now right click, new folder. You create a folder CA in the home directory. Okay. In the home directory, you create a CA folder. Go to the home here, create the CA folder. And now I'm going into the CA folder, and we will create multiple directories and files inside the folder. Okay. All right. So on the terminal also, I will go to the same place. So I go out. All right, and here I go to home, then to the CyberSec server, then to the CA folder, and I print my working directory. I am in CA now. Perfect. This is where we should be. Okay. So we create a CA folder, and we go to the CA folder in the home directory. Okay. All right. So follow the steps. Next, we need to actually, as I said, we need to create the environment. So we need a configuration file first. This is very, very sensitive, guys. We don't want to mess up with the original file, so we have to copy the original file. This is the file we need, open ssl.cnf. This is a configuration file. We're going to copy it from the original place and in our current directory. So we are copying it, okay? This means, so copy is just CP, your source path, right? And your destination path. That's simple. Copy to from, okay? Just like that. So this is a to, this is a whole path, and this is a, this is a from, and this is a to, okay? So we're copying from here to our, wherever we are standing. This means wherever I am, or you can explicitly mention if you are comfortable with that. Anyway, so we'll go to user lab SSL and copy the file. So copy from user lab SSL, the open SSL.cnf file to our current folder, and you can see that they are already shown up. Ooh, all right. So everything is based on this configuration file, and we need this configuration file here. Okay. Now that I have the configuration file, I actually want to make a slight change in it, because by default, the configuration file is directory is demo.ca. We don't want that. We want to remove demo.ca. Okay, we want to tell the file that our directory is our current directory. So we will just leave dot and / there. We will remove demo.ca. So it should look like this. Okay. So I'm going to open the CNF just like we used to open in the previous classes, and edit it in this line to my current working directory. So sudo nano SSL, and it will ask me for the password, and go using the keyboard all the way to directory, and there you go. I want to change this demo.ca, delete this to this, and save it. Control X, save, yes, and done. Okay. So we need to adjust the path. So after this, our configuration file is ready to be used. But we need actually 3 directories and 2 files to be created. This is what we are going to do. We are, Linux can actually execute multiple commands in a single line. So we are actually creating these 3 directories, 1, 2, 3. Okay, so we are creating certs folder, we are creating CRL folder, we are creating new certs folder. So all these 3 directories in one line. Okay. And then after that, we are creating 2 files. One is index.txt and one is serial without any extension. These are required for a CA to work actually. So that's, just we are actually creating the environment, as I said. So we create these 3 folders, this file and this file. Okay. So normally when you create a file, you would see that the file has at least 1 KB by default. That is the size of a file. Okay. But if you use the touch command, it will create the file with 0 KB, and that is what we want. Okay, so that is where the touch keywords come into play. And for the echo means actually whatever you're typing, it will print the same. But in this case, we are saying that move whatever the string here is, write it on this file. Okay, if this file doesn't exist, it will be created and this will be written on the file as well. So like killing 2 birds with 1 stone. Okay, so in all, we are creating 3 directories and 2 files. Let's do that. The cert, CRL, new certs, please keep the name exactly the same. Don't improvise, don't make any changes, don't play with the letters, capital, small, no plural, singulars, exactly as they are, because that is what CA would require. Okay, certs, CRL, new certs. So let's go there. We want to create certs, CRL, new certs. Okay, so as soon as you do that, cert, CRL, new certs, enter, you will see the 3 directories created there. Perfect. Okay, and the next step is to create the file touch with using the touch command index.txt. Okay, so we'll do that. And just to show you this command, this file we created, index.txt, has 0. The size is 0. All right. So that's the beauty of touch command. Okay, so for the last part, we are actually writing it into the serial file. Okay, and we have the serial file. You see 01 is already in there. If you open this file, you will see it already have a 01, which we just moved in. So yeah, now that you have done this, we are ready for creating the public and private key for the certificate authority. Okay, so let's go ahead, and everything is ready. And if everything was already ready, we just need one command, one line actually. Using the OpenSSL, we are requesting now. Okay. Previously we used ENC, remember? Now we are requesting a new standard certificate, a new, keys will be one public key and other private key. This is actually private key, this is a public key. These are just the names, it can be any name, using the configuration file, which we just tweaked a little bit. Okay, so we are requesting a pair of public and private key, right? So we will have public and private key, and then we can actually send the public key to anybody who wants to be our client. Okay, so this is the command which we need to execute at the same place. All right, so let's go ahead and do that. Might have entered wrong, just click here. Okay, open SSL. We want to request a new X.509 standards using that standard. We want to create a public key and a private key, private and public key, using the configuration open SSL. Now it asks for the passphrase. You always use cybersec just to be safe side. Cybersec to confirm, and it needs some information to be filled in. Please make sure you fill in exactly the same information, because your client would need to be to use the same information. Okay. AU is the country, state is NSW, locality is Sydney. You see Sydney is S is capital only. Organization is UTS, keep it capital, all cap. FEIT is organization, company is UTS. Okay, domain name we will give it cybersec.com.au, and the email address has to be given as well, so we will just give it a domain, cybersec.com.au, root@cybersec.com.au. Okay, so once we are given these values, you see we have a pair of public and private key. Okay, so this command, using this command, you will see putting in the values exactly. Please make sure this Sydney S is capital and rest are all capital. The domain names are all in lowercase. So once you did that, you will get a private key. So the key is a private key. We will not share it with anybody. And this is a public key. Anybody can have it. Okay. So our client will take this and it will create its own request. Okay, it will make a request to us. Okay, we call it certificate request, CSR. The client will send us that. It's kind of a public key of that client. And we will use that request to generate a certificate, some kind of certificate, and send it back. All right, so now we have this public key to share with us, our client, and this is our private key. We're never going to share it with anybody. Okay, so that's task 2. Now for task 3, we have to go to the client. No, the client needs a public and private key, right? So because they don't have it, so we have to do the hard work. So let's create the public and private key for the client, and then the public key for the client, and then send it to the CA. I mean, where are we sending? We are just here, right? Then we will create the request. The certificate for the client. So there are these 3 steps. It says 3 steps, right? So 3 steps means first we will create its private key. Then we will create its public key, which will also act as a request, which it will send to CA. And then CA, when CA sends back, that will be our certificate. So these are the 3 steps. Okay, 1, 2, and 3. So let's do that one by one. It's just the commands which we need to use. Okay, so we are using RSA all the time, right? AES encryption 128, and this is the command which you use. OpenSSL, create the RSA using this algorithm, and our private key server.key. Okay, this is the private key we are generating, and the encryption level is 1024. The higher the better, but then this gets slower as well, so you have to be. So okay, creating the private key. So the private key's name is server.key 1024. That's the encryption level. Oops, I did miss something. Open SSL, gen SRSA, and there's no hash. But okay. So passphrase always will be cybersec, verifying, done. So I got myself server key. Okay, so that's my private, that's the private key of the client. Okay, and this is the private key of the CA. All right, now let's create a request which we will send to CA, and then CA will create us a certificate. All right, so oh yeah, we also call that CSR. That's nothing else but just a public key. We will create that and send it to the, the CA. And how do we do that? We use, again, we are making a request to create a new key from our private key and making a public key, which we will send to the server, to the CA. And of course, we're using the configuration file the same all the time. All right. So let's do that. Open SSL. So we are requesting a new key using our private key. I mean, as a client, right? Using our private key, we want to create a public key, which we will forward out to the server. And we are naming it as server.csr, a certificate signing request. And we use the configuration file of openssl.cnf all the time. Okay. OpenSAL. Oh, how did that happen? OpenSSL, come on. Okay, so enter the passphrase for the server, cybersec, AU, NSW, Sydney, UTS, FEIT, cybersec.com.au, root at cybersec.com.au, and challenge password. No, we will, it's an optional one. So challenge password and company name optional. We're just going to skip it. Just press enter on that, and there you go. We got ourselves a certificate signing request, which is a public key we are going to send to the CS, and CA combining with its public and private key will actually generate a certificate for us, which we can show off, put on our, people who want to browse cybersec.com.au so that they can load it on their browsers and then work. Okay. So put in all the values, and just for the extra attribute last two, leave them blank. Yeah, that's it. Okay, so we have server.csr now. This is a public key of the client, which will be sent to the CA. Okay, now that's the third task. So generating the, step 3 of the third task, generating the certificate. So the client sends the CSR file to the CA. The CA does some magic and sends him back the CRT certificate, which then he can put on the, which we can then load on our browsers, and then our browser will trust this guy. Let's create this server.crt. So now this time the CA, we're using the certificate authority, which is using the CSR, which we just received, right, from the client, to create the certificate for the client using our public and private keys there and the configuration of OpenSSL. So we are going to actually send this to the client after we create this. Okay. All right. So let's do that. So OpenSSL. CA is generating server.cs using the server.csr, server, not server. That's the request we got. We want to create it a certificate for the guy, and using our public key and private key, the configuration of OpenSSL. Okay, and as a passphrase, cybersec. You want to sign the certificate? Yes. Are you sure? Commit? Yes. Done. There you go. We have server's certificate ready to be trusted by the browser and use. Okay, so that is task 3 for you guys. Now this certificate is available. Now how do we actually load it on the browser? How does the browser actually use it, right? So that is important thing as well. And what happens at the background? We easily go to the website and use it. For example, if you go to any website, let's suppose uts.edu, right? uts.edu.au, you go there, you see the browser is, secure, you read the certificate and you see it is trusted by a CA by the name of Kuavades, so UTS trusts this website, CA trusts this UTS, and our browser actually trusts it as well. That's why we are able to see it. If you look at the details, you can see where is the country of origin, all the domain name, what is the serial number, what is the public key algorithm used, what is the public key itself, so this itself is the long public key. You see, this is a public key. Everybody has, this is public key of UTS. Sorry for that. Yeah, that is for the UTS. And when is this certificate going to expire? 15th of January 2022. So UTS have to request for a new certificate before the time expires, of course. So you see, everything happens very easily for us. But what happens at the background is what we are doing. We are looking at now. And okay, close it. Okay. So how do we load it onto the browser? So first thing, again, we, since it's a VM, we have to do some extra bits to actually make it work. Remember last time in the last lab, we were actually, when we used the domain localhost, it was connected to netsec week3.com. This time we actually want to link it to cybersec.com.au. So we have to go to our hosts file and make that change. Okay, so let's go to the host file and map our localhost to this domain. So I'm going to go to the host file, sudo gedit hosts, and make this change. Okay, so our localhost is not netsec-week3 like last week. We are going to actually change it to cybersec.com.au. Okay. So I might be clicking somewhere else. Anyway, so sudo nano etc host cybersec nano is not nano, right? Okay. So you see, I've already changed it for the previous section, so it's good for me. You have to change it if it's your first time. So please do change it. Okay, make it cybersec.com.au. That's our local host. All good. Actually, I just want to exit it. Perfect. So my next step would be, again, few things more to do. We have to actually launch the web server, which will be using S server, and it needs a file server.pem. So we need to put both the certificates and the key in a single file. This key, the secret key, and the certificate both should be added in a same file. So your key is there, your certificate is there, both should be added in this file. Okay, this is the idea. This is a separate file, this is a separate file, right? We have to put them both together and make it one single file. Okay, that's what we are going to do. So how we do is we actually copy one of those in server.pem and we move the other one, add or concatenate it to the server.pem. Okay, so this is doing exactly what we wanted to do. For the first case, it's actually just copying it. So server.key is already copied. You know, your server.key comes here. It's in the server.pem. And in the second step, we are moving server.crt. The certificate is just concatenated. It's cat means, you know, just cat's actually catalog. We're adding it to the server.pem. So let's do that. So copy server.key to server.pem. Okay, copy server.key and create the new file, server.pem. Make sure the spellings are correct. And then also the certificate, we want to write it, we want to add it to the same file. Okay, keep doing that. Server. All right, so that's done. Now that's done, we can actually run our browser, a web server. So using this command, we can run the web server, and on top of this, we will run the browser. Okay. So using F server, we are running the browser, and the file is server.pem. So this is just a command to run the browser. Passphrase is server6. So it is running, right? When it says accept, it is running. Now on top of this, you will go to the browser, okay, and you will type in https serversec.com.au, okay, and the port we are using is 4433. 4433 is nothing else but just TLS, SSL TLS, okay. So let's launch it, run it, and if you run it as well, it will give you an option that, you know, the connection is not secure. For me, it is saying that, hey, your certificate is no longer valid, you know, because I was using a certificate for the previous section, which I deleted, okay, and it doesn't exist anymore. So to add the certificate, you have to go to the preferences, advanced, go to the certificates, view certificates. And for me, it's slightly different because I have to delete the existing one. So I have to go all the way to U, delete this certificate, all right. But for you, what you will do is you will actually import, go to the CA folder, your certificate, open it, and yes, you want it to trust everything. So this is, you're adding the certificate yourself, right? Normally all of this happens automatically on our browsers, Chrome, Firefox, Safari. But for ourselves, we have to actually manually do this. You see, there are other browsers already, CA is already there, Certum, VeriSign, and whatnot and whatnot. Anyway, so once we have added it, we okay it, and we go back and refresh the browser, and it should work. Okay, come on. Pressing enter, taking a while. There you go. Our website is up and running. Okay, so that's about it. You should get the message that your connection is not secure, which means, hey, I don't trust this website. So you say, okay, let's go and add the CA because we have a certificate. So you go to this certificates, you add the browser, you add the certificate there manually, and you make it trust everything and okay, and then you see it is already added, and you refresh the browser and it will open up. Okay, so what we did And the first task was simple. We just created an encryption file and it decrypted it. And we compared the SHA value as well, just as an extra tip, and see that they were same. Task 2, we became a CA. When becoming a CA means we had to have our own public-private key. We did the same for the client, made a public-private key, but the public key was a CSR as well, which we sent to the CA, and CA gave us a certificate. And at the last step, we use that certificate to run our website and the domain on a browser, and we loaded it on the browser. Okay. I hope this makes sense. And just as a reminder, I mean, these are the tasks which you can take as your challenge, you know. Otherwise, if you just want to follow the lab, it's okay. Use 2 times encryption on text file using different ciphers and compare the output. 2 times encrypt the image as well, you know. This is again optional, okay? If you want, it's up to you. Otherwise, you can follow the tasks which are already given to you. And these are the tasks which already I've done. Same task. This is just something to spice up. Okay. Next week, remember you have quiz. Okay. And we will have a lab as well, which is a very interesting attack called Dirty Cow attack. So first we will go through the quiz and then we will go through the lab. All right. And that's it. So let me know if you have any questions, guys. I'm gonna stop the recording and thank you.